Hello and a warm welcome back on this rainy sunny day at the end of the year. Where are we? Yeah, New Year's Eve I think we are. January 2022. Happy New Year to you all. I hope it's going to be a good one, although with the look of the last bugger it looks like it's going to be downhill all the bloody way. So ho ho ho, never mind. Today on the bench at long last is the valve preamp. As you can see, we've made a little bit of progress. This is the main chassis, as it were. The power supply, if you remember rightly, although it's that bleeding long ago, is separate. So this is a repurposed satellite doodah thing and modified power supply. So as you see, we've got a couple of valve holders mounted in. We've got our umbilical power in connector blobbed on there. This is the sort of best solution I can find at the moment with what components I've got to hand and having not much cash at all to spend on better components. These are the connectors that came off the original satellite doodahs. I found a couple of top hat screws on here to screw that in there, and that's to mount the socket on the outside, as it were, to get it all to fit. We don't want our HT high voltage power supply cable flopping about, so that's the best way I could find to secure it. And we're going to have to use some ink, whatever, we're going to have to use some heat shrink on there. I'm going to do something so that there should never be a high voltage here, just in case. So that goes in there, and then I have, if I can find it, I've made a little plate up. Woo! Only just painted it not long back, thank goodness this dries quickly, to cover up those holes. So there's going to be a valve holder in there, which will basically have the HT fused. We've got to think of protection. This isn't going to be mains earth reference. It doesn't need to be, as far as I'm aware, as there's no mains in or out of the thing. We do need to protect against a possible situation whereby the HT could be couldn't make the chassis live. There's a fuse there to stop that. So that's that bit. I'll put that aside. On the labelling front, we've got some progress. I'm not 100% happy about it, but again, it's using what I've got and doing the best job that I can. As you can see, I labelled them auxiliary 1, auxiliary 2, line 1, line 2. The line 1 thing there went a bit, Lee said best, yeah, that went a bit, I screwed up a bit on there when putting the nail varnish on top, because you have to protect these letters. The lettering is all done using Letraset or Decadry, as it's called. This came from Portugal. I didn't realise it was in Portugal when I ordered it. I ordered it off Etsy, which I've never ordered off before, and so I've got a bit of a sore throat, so my voice probably sounds a bit weird. Yeah, I ordered this from Etsy because the sheets that I had a look on eBay, and the sheets that were on there were about a tenner for half a used sheet, and not in the font or, you know, the lettering type that I wanted. So I got these. I think it worked out about a tenner in the end with postage. Not too bad, although I mean the letters all got little accents and whatnot over the top, but you can just, you know, leave them on the page, as it were, by not rubbing on them. As mentioned, if you don't know, you rub these. It's a dry transfer. It's a dry transfer. You rub with a stick, and the stick's got to be the right shape, otherwise it don't work properly. And you rub those on, doing the best you can by eye. I do that by eye, but what I do, this is the front panel. I've just done this one earlier on. I just put some tape on there just to try and give me a line to go onto. And as you can see here, what I've done here, I've just sort of made like a little box around that, because one of the things I don't like about this is that when you blob this, where do you call it, on nail varnish on, it, you know, it looks a bit blobby. Really, the best way I think would be, and I might try this in the future, although I've not had much luck with lacquer, is to do the lettering and then spray the whole thing with lacquer. However, I live in it's an old house. It was built in 1870 something. It's got an open fire, dust everywhere, and when I have tried to use lacquer in the past, like on motorbike tanks and everything, the finish when it's first applied looks absolutely fantastic. You can see the clouds floating by. Within about 5 minutes there's insects landing on it, bits of dust, and or then the finish just ends up looking like shit. And so with a bike tank I ended up like spending an inordinate amount of time like rubbing the bleeding thing down, spraying again. No, that one bogged up. So long story short, I'm not too enamoured with lacquering things, so I just go for blobbing a bit of nail varnish on. Although in the past I have used thin down lacquer. You have to be careful that, like as I did with that line one over there, that you, when you put it on, that you don't smudge it, because the lacquer, not the lacquer, the nail varnish does sort of dissolve the letters, it being some sort of plastic. Other ways there is, as far as I know, is like screen printing, but that's just mad for a one-off like this, and I don't know how I would get the, I don't know how I would do it in that sort of small lettering and detail, and for a one-off it's a bit mad. And then you can get from a place called Radio Days in America, I think it is, you can get like these water transfers, you know, like that you've used them like on old model aeroplanes when you were a kid, and you just sort of float them on and away you go. However, they're about a tenner for a sheet with volume on and everything. The font size is maybe not what you want. I think they're more designed for a sort of generic guitar amp. So again, to cut it short, that's the best I can do with what I've got. It doesn't look too bad. It could look worse. This is the underside of the chassis. We've got obviously the couple of valve bases on there. We've got a heater wiring on there. I've got a point where I, you know, like a ground point as it were. I did think of using these little tag boards that I pulled off some old test gear, but it's not really called for here. There's not that many components, it being quite a simple circuit. So I mean, this is just a very rough sort of thing that I did here. So we're going to have, if I can find them, this was off a previous amplifier that I did. A couple of high voltage caps, just mounting in a bit of, what do you call it, copper clad board. Couple of standoffs soldered on. They will fit in there. There's only 4 anodes, the 2 double triodes, each 6 CG7. So we've got one resistor to there, one resistor to there, and a couple of wires to the other anodes. So again, you know, that tag board would have been superfluous really. And then the same really with the ground type connections. There's only a few resistors, cathode resistor here, and then a couple of cathode resistors for the cathode followers. So yeah, keep it simple, I think that's the thing to do. Our, where do you call it, will go in there, our volume control will go in there, and our selector switch will go in there. I modified this because this is I think this is a 7-way connector, a 7-way switch, and I didn't need all the ways, we only need 4 ways. So what I did, I just made up this little bit of aluminium sort of doings here, just to act as a stop, and that's just secured there with a bit of nail varnish. good stuff, nail varnish. Use it for everything. So yeah, there we go. Not far off getting the thing done, I think. But we've got to make some decisions about what sort of, what value resistors and all the rest of it do we use. As you can see, the circuit is simple. I think I showed it you before. Couple of grid stoppers on the cathode follower and voltage amplification stage thingy. As mentioned, this is a constant current draw amplifier. So basically the anode of this is direct coupled to the cathode follower. We've got to make sure we work all these out, because the original uses 20k resistors and 430 ohm cathode resistor here and there. I haven't got 430 or 20k's, so I could use a couple of 10k's, but it's just a bit faffing about. But you can also use 18k and 220 ohm. However, I was worried about that, in that with the smaller anode resistor you've got more of a current draw, obviously, and I was a bit concerned where that would put a bias point. So let's work it out. This is our graph, our mutual conductance graph, or whatever you call it, for a 6CG7. Let's just say we've got 300 volts that originally that comes off the power supply. That will be knocked down a bit with a resistor and a decoupling cap. This is an RC filter, so that should filter off a bit more of the ripple, power supply ripple. So let's just choose, like, I don't know, i.e. 250 volts. 250 volts. I'm sure I've made a video about this before. It's very simple to work it all out. Get your calculator. I'm just using 250 volts. It could be anything, 230, 275, 250, and let's say we're going to use 18k. I have some 3 watt 18k resistors, so that seems like a good value to choose. Divided by 18,000 equals 13 milliamps, 13 and a bit, more or less 14, isn't it? And that will put us somewhere there. There we go, there. What I should do, I should just put something under this so we get a neat result. Alright, can we see that? Okay, so that's our load line. That don't look too bad. It's straight. It's at a, where do you call it, right angle to, it's nearly at a right angle to our grid lines. So then we've got to sort of figure out where we want to bias it. We want to keep away from -1 volts, so because we don't want to run into grid current. And I would also like to keep the current draw within reason, so we don't, otherwise you've got to use higher wattage resistors and what have you. So I would choose something like centre biased, about -4 volts. If we work that out, we say -4, that's at about 5 and a bit milliamps. Where are we? 4 divided by 0.00, hold on, that's right, 0.05 equals 800. Alright, that's a bit mad. I haven't got any 800, where do you call it, 800 ohm resistors. Higher, that'll be 7.5, cancel. 2, let's say 2, oh, come on, 2 divided by 0.0075. Okay, that gives us 260, no, you can't see. That gives us 266 ohms. So it just so happens that I have quite a few 270 ohm resistors. So that should, we can try that. So we'll bung that there. So your bias point will be there with 270 ohms. It'll be a bit more or a bit less, doesn't really matter. Now then, because our grid of a cathode follower will be at the same potential or same voltage as our previous stage, will that work out? I mean, last time I think I just used 20k and 470 ohm resistors, cathode resistors. So if we draw a line up there, and let's just say we're going to make this is at 0 volts. Our anode of a previous stage will be at about 100. Oh, there's a lot of bloody divisions on this thing. That's 150, that's 125. It's going to be a bit less than that, isn't it? Let's say it's 110, say. 110. And extend that line up. We've got to figure out where our cathode, the cathode follower, will be. Blop, blop, blop. 0. What's that? That is 50 volts. That's 100 volts. So we've got 100 and what's that going to be? Hold on. It's going to be at 150, isn't it? A bit less. I reckon at about 120. So that's not far off. That's not too bad. If our stage here is going to be at 110 and a cathode here is going to be at about 120, that will bias the cathode follower, because basically the load line is just the same, but we're just looking at the cathode. It's just like flipped on its head, if you're with us. So that means that our cathode will be sitting at, let's say, 120, so that means it will be biased roughly at 10 volts, which is no good, obviously, because that's more or less in cut-off. But there's a sort of magical sort of thing that happens with a direct coupled cathode follower, in that the cathode follower sort of adjusts to the voltage that's on its grid. It should be self-biasing, self-adjusting. So if we build that and test it at 250 volts and then take some actual voltage readings, then we can decide whether to use those values in the final build. So that would be 18k and 270 ohm, where do you call it, 270 ohm cathode resistor. This stage here and this stage here are both, because they're in a sort of like balanced state, be drawing the same current, and we reckon that they will be drawing about 7.5 milliamps. So that'll be 15 milliamps in total. And we said our anode here would be at about 100 volts, 100 and a bit, and a cathode there will be at about 120. So let's build that and let's see if that's the case. Here we are some time later. Soldered all the components in to our test circuit. So we've got 18k cathode and anode resistors, 400 and what have I got? No, sorry, 270k. Oh, what the frick am I talking about? And 270 ohm and 270 ohm cathode resistor. And so let's power it up. Heater's on. Applying HT. I haven't got the heater's reference to a high voltage at the moment. We'll call that out later. And because I'm powering it up slowly, we're alright. well, we're not really alright because the cathode is floating above the heaters, but we'll be okay, don't worry. Okay, let's just check what we've got there. I'm going to point you over here. So we're just testing DC voltages at the moment. 0 volts there. So I have done this previously. What am I frigging doing wrong? I've not got my lead on. Peanut. Right, let's check our anode. What did we say? We're going to be about 110. Right, we've got 120. Grid. Hello. 1.9 volts. That's not right. Should be 0. Cathode 2 volts. Well, that's not good. That's really not good. And so this happened to me earlier on. I thought, what? 2 volts on the grid? That's not right. Right. I'm going to put this on my grid. 2 volts. Ha ha ha! What? There. I'll show you what I did wrong in a minute. So now let's take our readings again. Right, okay, so the anode has gone up to 131 volts. Anode 130 V-ish, G, K, A, G, K. Grid is 0 volts-ish. What's a cathode now? We said we wanted it at 2 volts, didn't we? Oops. And we've got 1.5. There's a reason for all this, but this is the beauty of valves. Right, we know what an anode is on a second triode because it's... Right, we've got 131 there. And our grid of our cathode follower, what did I just say, 131. Right, let's check our cathode. 131.8. 131.8. Right, I'll do some grid cathode readings in a minute. That's it, isn't it? Okay. Let me just have a computation. One moment. Okie dokie. Let me just turn this down. Turn the power supplies off. I've just got it on my high voltage power supply and bench supply for the heaters. So our figures are a bit out compared to what I calculated them to be. Part of that is because, and they're not quite where they should be. So, well, I keep talking in the northern accent, apologies. So, we reckoned our anode would be at about 110 volts, and it isn't, it's 130. We wanted our grid cathode voltage to be 2 volts, it isn't, it's at 1.5 volts. Part of that is because it's unbypassed, and yeah, it's probably because I didn't calculate it very well. What else? Right, our cathode follower grid cathode voltage is only 0.5 volts, which is a bit iffy. Not really happy about that. That wants to be more, but cathode followers are tricky because the cathode follows the grid. So the more you try and adjust the thing to get it within a proper grid bias, you know, the more you try to alter it to get the correct grid bias, the more it sort of runs away. I've had this sort of issue before. Won't get into that just now because it's getting a bit late and I want to get this video finished. Anyway, well, the thing's working-ish. The reason why the voltage amplification stage grid was floating at 2 volts was because here's our volume control potentiometer. That's obviously got a ground. Here's its ground. What I hadn't done, I'd connected it to the grid, but I hadn't grounded it, so all I was doing there was just grounding it. So that was a foobar on my account. So let's see what happens when we bunker signalling. There we are then, all powered up. We're up on this scope at the moment because those other two aren't working. As you can see, we've got a nice clean sine wave. Try not to wobble too much. And that is it's dodgy because I've got a dodgy solder joint here. And turn this off. So that's working okay. What the actual distortion figure is and all that sort of majazz, I'm not quite sure, obviously, because I haven't got it all hooked up properly to my test gear. So the circuit's working to all intents and purposes. We've just got to continue on now, finish the front panel, mount the back panel, wire it all up to the selection switch, and do quite a few other bits and bobs. But at least we're making progress, which is always a good thing. Thank you very much for watching once again. Take care of yourselves. Happy New Year. Ta-ra for now.